This video will look at the problems in the suggested practice problems for exam 2 using basic trigonometry. For this first problem, let's just see what the problem says. A right triangle is formed with a hypotenuse length of 10. If one of the interior angles is labeled theta and the sine of theta is 1/4, draw the triangle with theta and the lengths of the two legs correctly labeled. So let's just start by drawing a right triangle. So we draw a right triangle. And what do we know? We know that the hypotenuse length is 10. The hypotenuse is the side opposite the right angle. And so our hypotenuse is 10. We want to label one of our interior angles as a 1/4, and it says that the sine of the angle is a 1/4. So this tells us, remember that the sine of an angle is the opposite over the hypotenuse. So the opposite is 1/4 the length of the hypotenuse. So based on my triangle, I will want to put theta here, and 1/4 of 10, so 1/4 is equal to the opposite over the hypotenuse, and so my opposite length is 1/4 of 10, which is 5/2, or in decimal, that is 2.5. So this opposite side is 5/2. Now I still need to find the other side, the cosine, the adjacent side, and I can do that using the Pythagorean Theorem. So if I call this unknown x, I know that x squared plus 5/2 squared is going to equal the hypotenuse squared. So let's simplify. X squared plus 25/4 equals 100, which happens to be 400/4. So that if I solve for x squared, I get 400 minus 25, that's 375/4. So that tells me x is the square root of 375 over the square root of 4, which is over 2. And 375 is a multiple of 25. How many? 375, well, 400 is 25 times 16, so that's 15, 5 square root of 15. So what I found is my x is the square root of 375/2, which simplified was 5 square root of 15 over 2. Our second problem, let's read it. To look at the top of a building, your line of sight makes an angle of 70 degrees with the ground. You are standing 50 feet from the building. How tall is it? Alright, well, this tells us, let's draw a picture. So we'll start with our building. Here we are standing. And when I look up to the building, my line of sight forms an angle of 70 degrees. And we know that we're standing 50 feet away. Well, now that we've labeled, let's identify what our question is. We want to know how tall is the building, and that would be the height of my building. So, oh, by the way, we are in fact neglecting the height of the person. We'll just ignore that, although if you want to, you could add about 5 feet at the end if you want it to be more precise. Alright, well, we know the adjacent side. We want to find the opposite side, and so this tells me that I should use the tangent function. The tangent of an angle is the opposite divided by adjacent. And so for us, the tangent of 70 degrees is going to be equal to the unknown opposite divided by our adjacent, which is 50 feet. And I can now solve for y. My y is 50 times the tangent of 70 degrees in feet. And then I can use a calculator to find the specific value. So that when we use our calculator, we get a total of 137.37 approximately feet. And that's how tall the building would be. Our third question asks how many degrees correspond to 5/9 of a full circle. So, well, a full circle is equal to 360 degrees. So 5/9 of a circle would be 5/9 of 360 degrees. So 360 divided by 9 is 40. 40 times 5 is 200 degrees. If I want to think about this in radians, a full circle is 2 pi radians. And so 5/9 of a circle would be 5/9 of 2 pi when measured in radians, which gives us an exact value of 10 pi over 9 radians. And to draw this on a unit circle, in standard position we always start from 0, and we want to go in the positive direction, so we're going to go in the positive direction 10 pi over 9 radians. Well, every pi gets me here, and so pi/9, we go pi/9 further, and this would be 10 pi over 9 in radians, which is the same as 200 degrees. So this angle that we would have is a 20-degree angle, because pi radians is the same as 180 degrees. So this angle would be 20 degrees. And so we're in quadrant 3. Our fourth problem asks, well, it tells us we're given an arc of 40 degrees and the radius is 5 feet. What is the arc length and what is the area of the sector? So whenever I'm doing these arc length or area problems, I want to figure out what fraction of the whole circle. So in this problem I was given the angle in degrees. So 40 degrees, I want to figure out of a full circle, what do I have? So 40 divided by 360 is 1/9 of a circle. So when I want to calculate the arc length, my S equals my arc length. This should be 1/9 of the circumference. So I can use my circumference formula, 2 pi r, 1/9 of 2 pi times r, which was 5 feet. And so I get 10 pi over 9 feet. And in decimal values, this would approximately be 3.49 feet. Notice I'm giving the exact value, not just the decimal value. I need to know the exact value. When I'm calculating the area of the arc, the area of the sector is going to be 1/9 the formula for the area of a full circle, which is pi r squared. So for us, our radius was 5, and so we'll get 25 pi over 9 square feet. And in decimal value, using the value pi is approximately 3.14159265, we can find that our area is approximately 8.727 square feet. The last problem in this section says we have an equilateral triangle with sides of length 4 feet. And our question is, what is the area of the triangle? So if I were to draw a picture, I've got a triangle that's equilateral and each side is 4 feet. We want to find the area of the triangle. And we need to start by remembering that the area of a triangle is 1/2 the base times the height. And the reason that this is in our trigonometry questions is that we actually don't know the height. So if I were to think about the height is this length of the from the base to the tip, where I form a right angle. So in reality, I'm recognizing that there is this triangle where I have got a hypotenuse of 2, half of that base is, the hypotenuse is 4, half of the base is 2, and we don't know the height. So one way to do this is to recognize that this is actually a 30, 60, 90 triangle. So this is 30 degrees, 60 degrees, 90 degrees, and we can calculate that height. Or I could use the fact that this is a Pythagorean triangle. The Pythagorean Theorem works. So h squared plus 2 squared equals 4 squared. In other words, h squared plus 4 equals 16. H squared equals 12. So what we find is that my height is the square root of 12 feet, which is 2 square root of 3 feet. And so I can now plug this into my formula. My area is 1/2 the base, which is 4 feet, times the height, which is 2 square root of 3 feet, and area is feet squared. So I have, see, the 2's cancel, so I get 4 square roots of 3 square feet. And using a calculator to find the decimal value, we have an area of approximately 6.928 square feet. 6.928 square feet.